All right. We are here today again to do it together. This is GMAETS 41. You are welcome to our live stream section as we kick off with JAM exam focus review in preparation for the upcoming JAM examination. Once again, I say welcome to you, friends, to this live stream section. Today's class, we are going to focus on chemical equilibrium. Chemical equilibrium. As always, I have to share this information with friends so that they can join the live stream class. Don't forget, these questions that are going to be treated, we already have them, right? Yeah, because these are questions generated from students, and we're going to give answers to them. Of course, there are others too that I'm going to add up in the process, okay? So let us get this done, like I said. If you are yet to learn the concept of chemical equilibrium, please note that you can actually get the video lesson on the GMAETS 41's platform, okay? So as to get important concept of what chemical equilibrium is much about. But as a quick summary, all right? As a quick summary, when you deal with chemical equilibrium, we are interested in chemical reactions whereby the rate of forward reaction is equal to the rate of backward reaction. Please, if you can hear me as this class is in progress, indicate by typing I can hear. Indicate by typing I can hear so that I can kick off the class quickly. If you can hear me, please indicate once you join the class. Give this live stream section thumbs up. All right? Type I can hear. That's good. Michael, you're welcome to the class. No, there is no time. This class was meant to have started 11 o'clock a.m. And of course, as you join, we kick off right away. I hope and look forward to seeing other friends join us. Like I said, the questions we are going to consider in this live stream section under chemical equilibrium, they're already available, and as usual, I'm going to dictate them, all right? I'm going to dictate them. All right, John Paul, you're welcome to the class. And as I dictate these questions, follow along, okay? When necessary, I will make analysis on the board. All right. Without wasting time, let's move on. These are questions provided by Group 3 of the GMAETS 41's JAM lesson class. Okay? So let us move on with our very first question. It's on chemical equilibrium, like I said. I'm sorry I couldn't go further to make a summary of chemical equilibrium. Like I said, on this channel, you have the video lessons, all right, that deals with chemical equilibrium. The first question we have here is, for the reaction A, gives you product B. The equilibrium constant K is given by K equal to concentration of B divided by concentration of A. If concentration of B equals 0.5 molar and concentration of A equals 0.2 molar, what is the value of K? And before I read out the options, please, look at what we've got. This is question 1. So this is the reaction given. We have something like this. This is the reaction given, and it is an equilibrium reaction, of course. So the equilibrium constant is given as what? The equilibrium constant K is given as what? Okay? The question goes further to say the equilibrium constant is given as concentration of B divided by concentration of A. That square bracket as used here means concentration. Okay, so that is it. We are given that. And the question went further to say that concentration of B is equal to 0.5 molar. This molar means moles per dm cube or mole per liter. That's the unit of concentration, mole per dm cube or mole per liter. Then the concentration of A was given as 0.2 molar. 0.2 molar. What is the value of K? The value of K we don't know. So that's the question, all right? Now, I'm going to read the question once and go straight to the options, then we solve. For the reaction, A produces B, you know, as you have then on the board. The equilibrium constant K is given by K equal to concentration of B divided by concentration of A. If concentration of B equals 0.5 molar, concentration of if concentration of B equals 0.5 molar and concentration of A equals 0.2 molar, what is the value of K? Option A, 2.5, option B, 1.25, option C, 0.4, option D, 0.25. So that's the question. And we're going to see how we solve that solution to this, okay? Now we are given that K is equal to this concentration. The examiner has already done a good job for us, you know. Ebere, you're welcome. Mercy, you're welcome to the class. Now, you are given the formula already. So the examiner has actually done you good. This is the equilibrium constant formula for this reaction. Because equilibrium constant formula is actually K equal to the multiplication of the concentration of the products divided by the multiplication of the concentration of the reactant. Simply put, K is equal to concentration of whatever you have in the product, you multiply them, divided by the product or the multiplication of the concentration of the reactant. So the formula has been given and the value of the concentrations have also been given. So it's just to substitute. In place of concentration of B, I'm going to fix 0.5 molar. Then I'm dividing it by concentration of A, which is 0.2 molar. Now you're in the exam hall, you have to solve this, you know, without calculator supposedly. Because like I said, the calculator in the systems, in the JAM system, right? I don't know, it will rather, for me, waste students' time. That is why in my classes, I always advise students to learn the basis of multiplication table, very important, at least from 2 to 9 times table. It's going to do lots of wonders for you. So how can you actually divide this without calculator? If you look at each of them is 1 decimal, 1 decimal. So multiply top and bottom by 10. If you multiply that top by 10, you're going to get 5 over. Multiply 0.2 by 10, you're going to get 2. Then you work on this. 2 can divide 5. How many times? 2 times, remainder 1. So it's going to be that 2 whole number of times, 2 times. Put points. That remainder 1, attach 0 to it, and then you get 10. Divide 10 by this denominator 2, you get 5. So the correct answer for the equilibrium constant for this question is 2.5. And that goes with option A. That goes with option A. All right, let's move on straight to the second question. Question number 2. In that question number 2, please, before I dictate it, I'm going to give you what we have here. K is equal to 1.2 times 10 to the power of 4. And then we have divided by 1 plus 0.5 times 10 to the power of minus 3. And then times concentration of C. Something like this was given. Good. And then we have C, concentration of C is given to be equal to 0.02 molar. We are now asked what is the value of K. So we have this information so that as I dictate the question, you can follow through. The equilibrium constant K for a reaction is given by what we have on the board here. That is K equal to 1.2 times 10 to the power of 4 all over 1 plus 0.5 times 10 to the power of minus 3, and then times concentration of C, times concentration of C. And so we now have this. If concentration of C equals 0.02 molar, what is the value of K? What is the value of K? Now listen to the options. 1.2 times 10 to the power of 4, that's option A. Then option B, 1.0 times 10 to the power of 4. Option C, 0.8 times 10 to the power of 4. Option D, 0.6 times 10 to the power of 4. That is the option given. Can I read the question once again? Follow through. I'm going to be fast this time around. The equilibrium constant K for a reaction is given by K equal to 1.2 times 10 to the power of 4 all over 1 plus 0.5 times 10 to the power of 3. Then times concentration of C, as you see here. If concentration of C equals 0.02 molar, what is the value of K? Then we have the options A, 1.2 times 10 to the power of 4, B, 1.0 times 10 to the power of 4, C, 0.8 times 10 to the power of 4, and D, 0.6 times 10 to the power of 4. Now, how do we deal with this question? Once again, you can see the equilibrium constant formula for that reaction has been given to you. So all you have to do is simple. Your K is going to be equal to 1.2 times 10 to the power of 4 divided by 1 plus 0.5 times 10 to the power of minus 3. Now the concentration value has been given to us. The concentration is 0.02. So this is times 0.02. That's the value of this concentration. Now this concentration of C is multiplying this value 0.5 times 10 to the power of minus 3. So what do? Following board mass, you have to multiply out this part first. Anything you get, you add it to this one. Now I'm going to tell you something about the importance of the knowledge of standard form, writing numbers in standard form, because that's what I can quickly use to deal with this, assuming there is no calculator. What I have to do is to convert 0.02 to standard form. 0.02 is the same as 2 times 10 to the power of minus 2. Let me indicate that this you are seeing here is the same as 2 times 10 to the power of minus 2. That being the case, I am going to multiply this 2 by 0.5. 2 times 0.5 will give you 1. I'm trying to use the law of indices, multiplication law of indices. Okay? Multiply this 2 by 0.5, you're going to get 1. Then this 0.5 has times 10 raised to power minus 3. This 2 has times 10 raised to power minus 2. According to multiplication law of indices, when you are multiplying 2 or more bases, you are expected to 2 or more the same bases, take note. You are meant to pick one of the base and then add their powers. So this 10 raised to power minus 3 times 10 raised to power minus 2, you have 10 as the base. Pick one of the 10s and add their powers. If you add minus 3 to minus 2, you're going to get minus 5. So what I'm saying in essence is this denominator is actually 1 plus 1 times 10 raised to power minus 5. I repeat, 1 plus 1 times 10 raised to power minus 5. So K is equal to 1.2 times 10 to the power of 4 divided by 1 plus 1 times 10 to the power of minus 5. This is cool, right? Remember, one could use calculator to deal with this, but I still maintain if you're seated for JAMB exam, you see, numbers like these, the truth of the matter is, it will be preferable you solve it using the network of your brain than going to use the system's calculator. Yeah. If you were allowed to use normal calculator, right, you can easily press this out. But I feel the time it will take to drag mouse from this to that, to click the numbers and stuff like that, it could be wasting it. So with good knowledge of multiplication, right, you can deal with all these stuff. And of course, certain knowledge of mathematical processes. So from here, we are going to add this 1 to 1 times 10 raised to the power of minus 5. But this is the fastest thing I can do per se. Are you following, right? I would rewrite this as 1.2 times 10 to the power of 4 and then divided by this 1 times 10 to the power of minus 5 is the same as 0.00001. Yeah. So if you add this to this, you are going to get, okay, let me show the working still, 0.00001. Because 1 times 10 to the power of minus 5 is simply dividing 1 by 10 to the power of 5. That's the meaning. So if you add up this, you would get something like 1.00001. So that K will now be equal to 1.2 times 10 to the power of 4. Let me show you something. If I write this as 1 plus 0.00001, take note that this 1 will add up to this 0 whole number parts to give you 1.00001. Which, of course, if you look at that, you can approximate it. This denominator is approximately equal to 1. So that 1.2 times 10 to the power of 4 divided by that approximate value here, which is 1, like I said, your answer will still give you that numerator, 1.2 times 10 to the power of 4. A good knowledge of basic arithmetics in mathematics helps you out in all of these stuffs. Going to the option, the correct answer is option A, 1.2 times 10 to the power of 4. I hope this makes sense, right? If you have any question, remember, you can always ask, and we'll follow through with responding to your question. All right. You can go through what you have here on the board before I wipe it for us to move on to question number 3. You're all welcome to the class. See you friends there. Share the links to your friend, okay? Share the link to your friends. Invite them to join this class, all right? So that they can be coached in the processes about chemical equilibrium. We are moving. We shall be looking at the third question this time around. Question number 3. This is not calculation, so I will just possibly fix the answer somewhere here. The question reads, the position of equilibrium in a reversible reaction is affected by the position of equilibrium in a reversible reaction is affected by this position of equilibrium we are talking about is the position of K, equilibrium constant. So that position of that guy as to whether it is going to the left or going to the right is affected by what? That's what the question is all about. Option A, particle size of the reactant. Particle size of the reactant. Option B, vigorous stirring of the reaction mixture. Vigorous stirring of the reaction mixture. Option C, presence of catalyst. Presence of catalyst. Option D, change in concentration of a reactant. Change in concentration of a reactant. Of these options provided, the correct option is option D. Option D, change in concentration of a reactant, is a factor that affects equilibrium during equilibrium reaction. The other factors mentioned do not affect equilibrium constant. As a matter of fact, you want to take note that factors that affect equilibrium constant include 1. Temperature. 2. Pressure. 3. Concentration. These are the 3 basic factors that affect equilibrium. Catalyst does not affect it. Catalyst only alters the rate of reaction. Okay, helping the reaction neither to reach, equilibrium faster or not. Do you get that? It does not affect equilibrium constant. So you want to take note of that fact. The correct answer, like I said, is D, and I've also given out the information about the factors that affect equilibrium. By that equilibrium, it is K, equilibrium constant we're talking about. So I can say the correct answer there is D. Okay, concentration. That's what affects equilibrium as given in the options that we have there. All right. Let us move on to the fourth question. Which of the following factors would not affect the equilibrium constant? Which of the following factors would not affect the equilibrium constant? Once again, no calculation. And so we're going to use this part to answer the question. A, concentration. Concentration affects equilibrium position. Take note. It affects equilibrium constant. Now the question is asking which one does not affect it. B, temperature. Temperature affects it. I just talked about that in question 3. C, pressure. Pressure affects it. D, volume. This question is dicey. It's kind of tricky somehow, right? Because volume has this relationship with pressure. As a matter of fact, when you are applying the CHARTELIER'S principle in the study of the effect of these factors on the equilibrium constant, pressure and volume go hand in hand. Because normally this question you're seeing here in the options provided, someone may say, okay, the correct answer should be volume. Because normally when we are listing the factors that affect equilibrium constant, we have pressure, we have temperature, we have concentration. We don't usually mention volume. So if I'm forced to choose an option, I will go for volume if I am forced. However, like I explained, volume actually affects it. Volume and pressure goes hand in hand. Volume and pressure go hand in hand. So classically, under real condition that let's analyze these to the core, I will actually conclude that the correct answer is not there. All these factors affect equilibrium. Are you following? Because when you talk about issue of volume and stuff like that, it has effect on pressure also. But anyway, let's just stick to the fact that basically when we're talking about the factors, we have these 3 mentioned: pressure, concentration, and temperature. And for that reason, for this question, say that I'm in exam hall, I will go for option D, volume, saying that it doesn't affect it. All right? But don't worry, as we move on, if we have any question where we are asked to check for the effect of pressure, you will see how volume also comes in. That is why I said, if I'm to sit with someone, say, okay, let us discuss this, right? Let's argue this concept. I think I would actually not say that volume doesn't affect. But for the sake of the exam, as it is here, we shall go for volume. So question number 4, we are saying D, volume. All right? Just for the sake of what we are doing now. Okay, so this is going to take us to question number 5. This is going to take us to question number 5. Let's see what we've got. Question 5 reads, if a catalyst is added to a system at equilibrium, if a catalyst is added to a system at equilibrium, and the temperature and pressure remain constant, there will be no effect on the A, activation energy of the reaction. That is not true. Catalysts affect activation energy. It either lowers or increases activation energy in the process. Yeah. So that's not the answer. We are looking for what will happen, right? If catalyst is added, that there will be no effect. What will catalyst not affect? That is what we are looking for in this option. Option A said activation energy, and I'm saying that is not the answer. Option B, rate of the forward reaction. That is not the answer. Option C, rate of the reverse reaction. That's not the answer. Option D, heat of reaction. That is the answer. Catalyst has no effect on heat of reaction. Yeah. But catalyst can alter activation energy in a way. If catalyst speeds up a chemical reaction, what it has done to the activation energy is to reduce the activation energy. All right? When you draw this energy profile diagram for endothermic and exothermic, I won't have enough time to analyze it on the board right here. But of course, we have video lesson that explains that. Okay? If you have the energy profile diagram it's something of this kind, then the graph goes this way. You must have seen it before for endothermic and exothermic reaction. That height that goes this way, that height is called the activation energy. So catalyst can either increase it or reduce it. If catalyst increases that height, which is the activation energy, are you following, right? Then we say that what the catalyst has done is to reduce the rate of reaction by increasing the activation energy. Then if the catalyst added to the system slows down the reaction, the rate of reaction, if it slows it down, right? What it has done, like I said, is to increase that activation energy, thereby slowing the reaction. But if the catalyst increases the rate of reaction, speeds it up, what it has done to activation energy, that height, is to reduce it, because once that activation energy is reduced, then reaction speeds up. I get the point, right? And so catalyst can affect activation energy, and you see in the little explanation I gave, I said something about speeding reaction, reducing reaction. That has to do with the forward reaction, the backward reaction. Are you following, right? Yeah. So catalyst has effect on these guys. Catalyst affect the rate of reaction. So what it does not affect here is the heat of reaction. Yeah. Catalyst has nothing to do with the heat of reaction. All right. So question number 5. The correct option again is D, heat of reaction. All right, I hope you are following up with the class. And I hope you are following up with the interpretation explanation given. We shall be moving on to question number 5. Question number 6, rather. Question number 6. That one is a calculation question. So I've got to wipe somewhere on the board. Okay? So I'm going to wipe this part to move on to the 6th question. All right, question number 6. I'm going to write certain things on the board before dictating the question. Question 6. Okay, Q6. Question number 6. Now we have this reaction, N2 gas plus 3H2 gas, and then under equilibrium reaction gives 2NH3 gas. Correct. Then towards the end of the question, we have this now, 2NH3 gas, and then producing, that's a kind of reverse reaction to this, producing nitrogen gas, and then hydrogen gas. That's good. I can now dictate the question. Follow along. The equilibrium constant K, for the reaction, this first reaction, for this reaction, the equilibrium constant K for the reaction, the first one, is, so K is equal to 6.0 times 10 to the power of 5, 6.0 times 10 to the power of 5 at 300 Kelvin, What is the equilibrium constant K? What is the equilibrium constant K for the reaction? This second one now. For this second reaction, ammonia, all right, producing nitrogen gas and hydrogen gas reversibly. What is going to be the equilibrium constant? So that's the question. Let me dictate the question again. The equilibrium constant K for the reaction, the first one, N2 gas plus 3H2 gas, undergoing equilibrium reaction to produce 2NH3 gas, that's ammonia gas. The equilibrium constant is 6.0 times 10 to the power of 5 at 300 Kelvin. What is the equilibrium constant for the reaction? This one now, 2NH3 gas, giving you nitrogen gas N2 plus hydrogen gas 3H2 gas. Now we have the options. A, 1.7 times 10 to the power of minus 6. B, 2.5 times 10 to the power of minus 6. C, 3.3 times 10 to the power of minus 6. D, 4.0 times 10 to the power of minus 6. How do we solve this problem? Now, if you look at this reaction, you observe that these two reactions, they are similar. The only thing is that for this one, we have these in such a way that nitrogen gas is reacting with hydrogen gas to give you ammonia. And because this reaction is reversible, we now have this where ammonia is dissociating under equilibrium still to produce back what gave us that ammonia initially. So you have this ammonia dissociating to give you nitrogen gas and hydrogen gas. The examiner gave you the equilibrium constant for this reaction. This is just like the forward reaction, and this one is just like the backward reaction. That's the implication of this question. So the examiner gave you the equilibrium constant for the first reaction, and then asked, when this reaction is reversed, what is going to be the equilibrium constant? Solving it is simple. Now I'm going to give you the formula for this. Now, generally, permit me to use this as the forward equilibrium constant. Because looking at this, when they gave us this 6.0 times 10 to the power of 5 as the equilibrium constant, that is when nitrogen gas and hydrogen are reacting to give you that forward product, ammonia. Now, they asked us to find the one of backward. So let me use KB for the backward reaction when ammonia is dissociating to give you nitrogen gas and hydrogen. The relationship between these two equilibrium constants is given as KF, KB, the backward equilibrium constant, equal to 1 all over KF, the forward equilibrium constant. So it's simple. One of the equilibrium constants is inverse of the other one. The forward equilibrium constant is 1 over the backward equilibrium constant. Just the inverse, that's it. So what we're going to do is to substitute. This is 1 divided by KF is 6 times 10 to the power of 5. Now, how can I solve this without calculator? Of course, you have to take this 10 raised to power 5 up. If 10 raised to power 5 is going up, it is going to become 10 raised to power minus 5. You know, when you are getting your answer, the options provided, not like, no fraction there, but even at that, you're solving this, you're meant to get a decimal number. You can see the options that we're given. So if the 10 raised to power 5 goes up, we are going to have on top 1 times 10 raised to power minus 5. Then, look at this one, look at this 6, divide them. Why I told you that this 10 raised to power 5 will have to go up is that this 1 standing alone, look at it, is the same as 1 times 10 raised to power, it is the same as 1 times 10 raised to power 5. Look at it. Times 10 raised to power 0 rather. This number standing alone is the same as 1 times 10 raised to power 0. So you apply division law of indices to this 10 to power 0, 10 to power 5. Move this 5 to meet power 0. The sign, the positive sign of this 5 will change. It goes up and become minus 5. I'm saying all these things because you need to be well prepared for stuff like this as you're going for your exam. So you are handling this 10 and this 10 using division law of indices, then working on this 1 and this 6. 1 divided by 6, let's see what we are going to get. 1 over 6. 6 cannot divide 1, so it's going to be 0. Remainder, that's 1 that 6 cannot divide. Now to handle the remainder, since we want our answer in decimal, I'm going to put points. Not in mixed fraction. I'm not getting the answer in mixed fraction. It's meant to be in decimal. So 1 over 6 is 0 times. 6 cannot divide 1. We'll be left with that 1 as a remainder. What do we do with the 1? Attach 0 to that 1, you get 10. And divide 10 by 6. 6 can divide 10 how many times? 1 time, remainder 4. What do you do with that remainder 4? Again, attach 0 to that 4, you get 40. Divide that 40 by 6 again. You see, you are working with 6 times table now to solve this. In 6 times table, 6 can divide 40. 6 can go into 40. How many times? 6 times. 6 times. That will be 36. So we still have a remainder of 4 again. What do you do? Attach 0 to that 4. You get 40. Divide that 40 by 6 again. You are going to get 6 times. Again, remainder 6. This is meant to continue 6, 6, 6, 6, 6 if you are working it out. Let me stop at this point, then multiply by 10 raised power minus 5. All right. Besides, if you look at the options given, you find out that the values are in 1 decimal. That is why I have to obtain this guy up to this 3 decimal, because I need to do some approximation here. This KB is equal to, move this point once this way. If it moves, it becomes 1.66. Then approximate this 6 to this 6, you get 7. So this is going to become 1.7. That's good. The knowledge of standard form in indices. Do you have any challenge with this? Remember, the GMAETS 41 is here to help you right away. On this channel, we'll have video lessons that cover the concept of indices and its laws, the concept of standard form, okay? So I can help you with these lessons, and you get to learn them. They are very important as you're preparing for this professional examination. And mind you, most exam bodies now are eliminating the use of calculators. Yeah, somehow, some way. So you want to train yourself to be able to match the conditions for these examinations. So we're going to have times 10. I move this point 1 time to the right. Since I moved to the right, I'm going to minus from this power, minus 5. I'm going to minus 1 from this power. And how many times did I move the point? I said 1. So this is going to be minus 5 minus 1, which gives you minus 6. And this is the equilibrium constant for this backward reaction. That's the answer. I hope you enjoyed the calculation. One of my worries for students whenever I teach, like I said, I'm not supposed to be explaining all these concepts, but I understand how some persons have this anxiety when it comes to maths. I want to tell you that maths is really, really an interesting and simple subject. Yeah. Develop this love for it. Find a coach to guide you. GMAETS 41 is here every time, like I said, for you friends. And I'm going to make maths something that you would always love. Maths is interesting. It's simple. As a matter of fact, our life generally is mathematics. That you have to connect to this class at this time is maths, because you calculated the time, right? You had to calculate, okay, I need to get data to be able to connect and stuff like that. You know what I'm talking about. Okay, so we are moving on. Peace. Sir, please, I still don't understand question number 5. Question number 5. Say you still do not understand question 5. Okay, I think I'll go back a little. That question 5 that asked, if a catalyst added to a system at equilibrium, if a catalyst is added to a system at equilibrium and the temperature and pressure remain constant, there will be no effect on the, all right? So, and I mentioned that there will be no effect on the heat of reaction. Let's see, what do you have to say there? A catalyst added to this. Okay. You didn't give any explanation to perhaps why you didn't understand that. Okay. But all the same, I'm going to explain what I said earlier. Catalyst affects the rate of reaction, right? Now, what it does is to alter activation energy. The way catalyst affects this thing is to alter activation energy. Okay, is to alter it. So, going back to that and see, now the temperature is constant. The pressure is also kept constant. Temperature is constant and pressure is also kept constant in the reaction. All right. So what will it not alter? What will it not affect? And I say it's not going to affect the heat of reaction. Yeah, it's not going to affect the heat of reaction because you see the temperature is constant. There will be no change. There will be no change in the heat of reaction. Right? That's what I said. It's going to affect the activation energy because, like I said, that's basically what catalyst does. Catalyst alters the rate of reaction. That's what it does. That's what it does. So what will not be affected there is the heat of reaction. Since pressure and temperature are kept what? Constant. You get that right? Okay, for further clarification, we could still discuss that. You can send a direct message after this live stream section. I will give further explanation to that. Okay? All right, we are moving on to the next question. We are moving on to the next question. And this next question, number 7. Number 7. However, take note, you can drop what you feel about the question, okay? You can drop what you feel about the question. We can still deal with that. Question number 7, I'll have to wipe this part of the board because I need to write some things on the board. Right, so question number 7. We have this question that said, consider the gas phase equilibrium. Consider the gas phase equilibrium system represented by the equation. This is the equation. 2 molecules of water. This water is in steam form, so gas. And then we have plus, no, it's not plus. That undergoes equilibrium reaction. We have something of this kind, and then it produces hydrogen gas, 2 molecules of hydrogen gas, and then 1 molecule of oxygen gas. Good. Consider the gas phase equilibrium system represented by the equation. This is the equation. Given that the forward reaction, in brackets, the conversion of left-hand species to right-hand species. Given that the forward reaction, in brackets, the conversion of left-hand species to right-hand species, you close your bracket, is endothermic. Which of the following changes will decrease the equilibrium amount of water? Which of the following changes will decrease the equilibrium amount of water? Option A, adding more oxygen. Option B, adding a solid phase catalyst. Option C, decreasing the volume of the container, in brackets, the total pressure increases. D, increasing the temperature at constant pressure. E, adding gas. So which of the following in the options provided will decrease the equilibrium amount of water, of H2O? Look at it. So we have those options. Now I'm going to analyze this question and then we'll visit the options once again as you see what the correct answer is. We are told in the question that the conversion of left-hand species to right-hand species is endothermic. That's what the question said, which means the forward reaction here is endothermic. If the forward is endothermic, automatically the backward will be exothermic. That is the implication. Like I said, on the GMAETS 41 platform, you have a dedicated video lesson to chemical equilibrium where I explain all these concepts fully. Are you following, right? Now, the examiner told us that the forward reaction is endothermic. Whenever the forward reaction is endothermic, it simply means that delta H is positive. Delta H is what? Positive. That's the implication. It means that delta H is what? Positive. That's when forward will be endothermic. Now we are being asked in the question, which of the following changes they decrease? What? Which of the following changes will decrease the equilibrium amount of water? Once again, which of the following changes will decrease the equilibrium amount of water? Now, the whole idea is this. We want this guy to decrease. For this guy to decrease, that is to say, water production is not favored. For this to happen, the equilibrium will have to go to the forward reaction. The equilibrium will go to the forward reaction so as to favor the production of the product. When the products are being produced, when their amount, their concentration increases, this guy, the reactant, will decrease. That's the implication. Now the examiner is interested, what can we do so that there will be decrease in the equilibrium amount of water? So we want to ask ourselves, what can lead to equilibrium going forward so that this guy will now reduce? Because wherever equilibrium is going to, whether forward or backward, right or left, that side, the concentration there will increase. All right? So that is just the main idea here. So this is what we do. Since the forward direction is endothermic, the effect of temperature on equilibrium. Effect of temperature on what? Equilibrium. Generally, if you increase temperature of a reaction, the endothermic direction will be favored. I repeat, if you increase temperature of a reaction, the endothermic direction will be favored. So more of the things in that endothermic direction will increase. But if you decrease temperature, the exothermic direction will be favored. Now, what will I have to do to temperature so that the forward direction, which is endothermic, will be favored, which will lead to a decrease in this guy? It is simply to increase the temperature of that system. If I increase the temperature of this system, the endothermic direction will be favored. Since the system, we are told that the forward direction is endothermic, delta H positive. It simply means that more of hydrogen gas and oxygen will be produced. And when more of hydrogen gas and oxygen are produced, it means that water production will reduce. The amount of water will do what? Reduce. So I have given the interpretation or explanation of what will happen to this system to decrease this. Let's now visit the option and see. If you look at the option, we have A, adding more oxygen. Now, if you add more oxygen here, effect of concentration on equilibrium. What effect of concentration tells us is that if you are adding more species anywhere, equilibrium will go to the other opposite side. So if I'm increasing the amount of oxygen, the equilibrium amount will shift to the left, favoring the production of water, thereby increasing it. But the examiner is requesting for what will lead to decrease of this guy. That is why option A is not correct, adding more oxygen. Adding more oxygen will push equilibrium to the left, increasing the amount of water. So A is off. B, adding a solid phase catalyst. That one has no effect on equilibrium. We've talked about that already. Catalyst does not affect equilibrium. So option B is off. C, decreasing the volume of the container. Decreasing the volume of the container. That is, the total pressure increases. That has no effect here. If you decrease, or if you increase rather the pressure, if you increase the pressure of this, according to Boyle's law, pressure is inversely proportional to volume. Now let me tell you what happens in that case. If you increase pressure, volume will decrease. So what equilibrium will do here is to go to the direction of decreasing volume, which is equal to the direction of increasing pressure. What does this mean? How many molecules of water do we have here? 2. Which means we have 2 volumes. That's the implication. How many molecules of this product do we have? Here is 2 plus 1. So the total volume in the product is 3. Here where we have water, volume is 2. Product, volume is 3. So if you increase pressure, look at what is going to happen. Increase in pressure will lead to decrease in volume. Then equilibrium will run to that side where volume is decreasing. And that side where volume is decreasing is where pressure is increasing. So here we have lower volume, 2 here and 3. So increasing pressure decreases volume, which means this is where equilibrium will come to. And if the equilibrium shifts to this side, you see more water will be produced there. But remember, in the option or in the question, we are looking for what will lead to decrease in the equilibrium amount of water. Therefore, option C is off. Option C will increase water production. Option D, increasing the temperature at constant pressure. Oh, God. Yeah. That's it. Increasing the temperature of the system. If you increase the temperature at constant pressure, like I said, increase in pressure, this is the reaction is positive in the forward direction. So if you increase the temperature of this, the equilibrium will shift to the right. When it goes to the right, more of hydrogen gas and oxygen gas will be produced, thereby reducing water molecule, the equilibrium amount of water. E, adding a gas, that one is off. All right. I took my time to explain this so you get the concept. And if you follow through my explanation of this question, I have touched the effect of concentration. I said something that in concentration, where you are adding, if you are adding something like in this case, you are adding to the product, equilibrium will go to the reactant. I've also taken my time to touch the effect of pressure. I said something that when you increase pressure, we know according to Boyle's law, volume will do what? Decrease. What equilibrium will do is to go to that direction of decreasing volume. Equilibrium always go in the opposite direction to what pressure is doing in that system. And conclusively, this question actually is about the effect of temperature on a system in equilibrium. Yeah, that's what this question is all about. And so I've succeeded to also explain how temperature affects equilibrium. And I hope you were able to follow through. So the correct answer here, like I said, is option D. Option D. What you have to do is increase temperature. Increase temperature at constant pressure. That will lead to a decrease in the equilibrium amount of water. Wow, this is cool. I hope you are following up with the class. If you have any question, don't worry, drop it. Like I said, I will attend to the questions possibly either within this period of the class or after the class. It all depends on what it will take for me to answer the question. All right, we are going to move on to the next question. All right. Peace, I can see your response to this question, decrease in temperature. However, I hope you followed my explanation, because decreasing temperature will not produce what the examiner is looking for here. If you decrease the pressure, the temperature of this system, like I said, decrease in temperature always favors the exothermic direction. And once any side is favored, more of the species on that side will be produced. So if you say that decreasing the temperature of this system is supposedly the answer, it means that more of water will be produced. But hey, what the examiner asked is, what will decrease equilibrium amount of water? So what will decrease it is increasing temperature. All right, let's move on to question number 8. It's not calculation, so I think we read and go straight. Question number 8. What is the term for the state in which the rates of forward and reverse reaction are equal and there is no net change in the concentration of reaction and product? It's meant to be in the concentration of reactant and product. I read the question again. What is the term for the state in which the rate of forward and reverse reaction are equal and there is no net change in the concentration of reactant and product? What is the term used to describe that in chemistry? Of course, that is equilibrium, chemical equilibrium. Now we have the options here. A, chemical reaction, no. B, chemical equilibrium, correct. C is catalyst, D is stoichiometry. They are not the options. The correct option here is B, chemical equilibrium. Chemical equilibrium. That is the term used to describe a situation, a state where the forward reaction is equal to the reverse or the backward reaction. And in such case, there is going to be no change in concentration of the reactant and product. Question number 9. What is the symbol for the equilibrium constant? What is the symbol for the equilibrium constant? You've seen it severally. Okay, the symbol of equilibrium constant we use is K, and that is option A there. No time to waste, is K. Option B, we have Q. C, we have DH. That DH is actually delta. This symbol, delta, is typographical stuff that caused it there. So delta H, that's not the symbol for equilibrium constant. Capital E is not the symbol for equilibrium constant. The correct answer is A, which is K. Question number 10 is the next one. Question 10. A catalyst increases the rate of chemical reaction by providing a path that, I read again, a catalyst increases the rate of chemical reaction by providing a path that, A, raise the activation energy. That's not the answer. If activation energy is raised, like I was explaining in terms of, okay, I think at this point I've got to just draw something. This is the energy profile diagram. We have just something like this. I'm assuming something like this. Okay, so something like, I think this is endothermic energy profile. So this one represents endo. We have the one for exo. Let me see if I can squeeze it here. We have the one for exo, which is something like this. Okay, get something like this, exothermic. Yeah, they think. Let's look at this and see. One of them is endo, the other one is exo. So based on this is the concept of activation energy we are talking about. This is the concept, like from here now to this place is the activation energy. So I can use EA for it. Then in this case, the activation energy goes this way, right? That's activation energy, EA. Good. All right, so in the question, a catalyst increases the rate of chemical reaction by providing a path that, A, raise the activation energy. If you raise this height, when these reactants are reacting, it will take them time and more energy to get to that greatest height before they will completely react and give you product. This is reactant, this is product, this reactant, this product. Are you following right? This reactant side, reactant, and here is product, the same as what we have there. Okay, reactant and product. So that option A is not the correct answer. B, increase the temperature. That's not the answer. C, lowers the activation energy. That is the answer. If a catalyst is added to a chemical reaction, if that reaction is the rate of reaction, if it increases, what the catalyst actually did there is to lower, reduce this height, reduce the energy, because this vertical line here is representing energy, right? This is energy and then time. Okay, guess so. So if this activation energy is reduced, it means that the reactant, they don't need too much energy to get to this point. We call this point the activated complex here. Activation complex. So if a catalyst lowers the rate of reaction, if a catalyst rather increases the rate of reaction, what simply happened is that the catalyst lowered the activation energy so as to achieve an increase in the rate of reaction. All right, we are moving on. I think I've mentioned that the correct answer to this question 10 is that's C, lowering of activation energy. Question 11, yeah, the statement volume is inversely proportional to pressure at a constant temperature is given by Boyle's law. That's option B. No time to waste there. Option B, Boyle's law. Question number 13. Question 13. At equilibrium, the concentrations of the reactant and product will be equal. That's option C. Option C. Question number 12. Option C. At equilibrium, all right? At equilibrium, I want to take note. that at equilibrium, the concentrations of reactant and product will be equal. Let's move on to our next question, number 13. What factors affect physical equilibrium? Question number 13. Question 13. What factors affect physical equilibrium? I don't know. Are you trying to write chemical equilibrium? Because you're dealing with chemistry here. I will go with the options we have here. A, temperature. B, pressure. C, concentration. D, all of the above. What factors affect physical equilibrium? A, temperature. B, pressure. C, concentration. D is all of the above. Yes, all the above three factors mentioned, they affect equilibrium. So the correct answer is D. Temperature, pressure, concentration, they affect it. So all of the above. The last question, as provided by our students in these questions we review, is question number 14. But that is not the last of this class. I'm not satisfied yet. You see, it's good. These questions provided, but there were other aspects of chemical equilibrium that I was expecting you friends to bring questions from, especially the effect of temperature, pressure, and concentration on equilibrium constant, on equilibrium position. So I've got some I would like to add up. Are you getting me right? A few before we conclude the class. But for the ones that our student posted here, we're on the 14th question, which is the last one. And question number 14 reads, the rate of the forward reaction in the equilibrium state is, I repeat, the rate of the forward reaction in the equilibrium state is A, equal to the rate of backward reaction. And of course, that's the answer. No time to waste. At equilibrium, rate of forward reaction is equal to the rate of backward reaction. We have other funny options like B, greater than the rate of the backward reaction is not true. At equilibrium, they are equal, like we say. C, not equal to the rate of the backward reaction is not true. D, lower than the rate of the backward reaction is not true. So you take note, the rate of forward reaction in the equilibrium state is equal to the rate of the backward reaction. That is option A. Number 14 is option A. Backward reaction, let me use, okay, forward reaction, let me use arrow F, is equal to backward reaction, let me use arrow B, at equilibrium, at equilibrium, at equilibrium. That's good. Now we've been able to do justice to these 14 questions. And I hope you learned something cool. For any new friends that connected to this class, if you are yet to subscribe to the GMAETS 41's channel, please consider doing that, okay? There is so much to learn from this channel. Yeah, so much. You can always share our video lessons to friends also and invite them to join our class as well too. We are done with the 14 questions. Like I said, there is one more question I'd just like us to consider, making number 15. Then on my own, I'll just release a pre-recorded video where I will still deal with questions on the effect of temperature, pressure, and concentration on equilibrium, because that is really an interesting part of this topic. Okay, so let me give you just one of the question, and we see what we've got here. Let's see. Please, my dear students, GMAETS 41's jump student, this question I'm about to give, you don't have it because I'm the one providing it. Like I said, I would have really loved to see more questions from that part, but it doesn't matter. You've done your part by providing the questions available to you, and that is interesting. We're going to take this particular question. Let's see what you're meant to know there. I'll be wiping this part of the board because it requires some things to be written on the board. Think I can wipe. Meanwhile, take note that at the end of this lesson, a copy of this video will be made available, so you can still check back to take the lesson once again. At that time, you can copy all these notes, these answers on the board and analysis. So this is the question. Let's make it question number 15. I'm going to write this on the board first. Cu2 plus aqueous, that's copper ion, plus ammonia gas, and then this is in equilibrium, producing, please let me write below here what we have so it doesn't cut off from your view. This is Cu in bracket NH3 4, and then we have 2 plus aqueous. Good. So follow along as I dictate the question. Cu2 plus, that is the copper 2 ion you have there, plus 4NH3 gas, that is 4 molecules of ammonia gas you have here, is in equilibrium with, this reaction was given like this. I'm just the one trying to interpret this grammatically. So this species is in equilibrium with this. This is copper 2 tetraamine. Copper 2 tetraamine, right? So this species is in equilibrium with this. In the reaction above, what is the effect of precipitating Cu2 plus ion? In the reaction above, what is the effect of precipitating copper 2 ion as copper sulfide? What is the effect of precipitating Cu2 plus as Cus? That's the question. Interesting, right? Now you are given this to be in equilibrium with this. What is the effect of precipitating this ion as copper sulfide? The idea is this. What is the effect of removing this? In this reaction, now look at it. The examiner asks, what is the effect of precipitating copper 2 ion as copper sulfide? When you precipitate something, what you do is to remove that thing from solution. That's the concept that is being used in salt analysis. Are you getting me right? Salt analysis is the same as qualitative analysis, where you will add one reagent into a solution and then something will start coming out. You hear stuff like white gelatinous precipitate, you hear like blue precipitate, you hear dirty green precipitate, gelatinous precipitate, and stuff like that, okay? Maybe you may have heard one of these, all right? Now, what is the effect of precipitating copper 2 ion? So that as you are bringing this out, it's coming out as copper sulfide. So what is the effect? That's the question. I'm going to dictate the options. A, there will be no effect. B, the equilibrium will shift to the right. C, more ammonia concentration will be generated. D, ammonia concentration will decrease. Let me take the options again. A, there will be no effect. B, the equilibrium will shift to the right. C, more ammonia concentration will be generated. D, ammonia concentration will decrease. Now, what should you know about this? Now, this question, since we are told that we are looking for a situation where we can remove this, that's the meaning of precipitating. Remove this, bring it out of solution as copper sulfide, right? It simply means that in this question, we are trying to study the effect of concentration on equilibrium. That's the meaning of that. Effect of concentration. Because when you are studying the effect of concentration on equilibrium, your interest is either you add a species to the reactant or you remove, as the case might be. You can add to the reactant, you can add to the product, you can remove from any one of them. Now, let me tell you the secret of what you should know and how to interpret the effect of concentration. If I have reactant and product here, and I am adding something to the reactant, which means I'm increasing the concentration of the reactant. Once you are adding anything to any side, whether to the reactant or to the product, let me explain this assuming I am adding something to the reactant. If you are adding something to a reactant, you are increasing the concentration of the reactant. What equilibrium will do is to shift to the other side that you are not adding anything. That's what equilibrium will do. Equilibrium will do what? Shift to where you are not adding anything. So if I'm adding something to the reactant, equilibrium will go to the product. It will favor forward reaction. It will shift to the right. If I'm adding something to the product, equilibrium will shift from there to the opposite side, which is to the reactant, to the left. That is, if I'm increasing concentration of products now, the equilibrium will move to the left. So you see the idea. Wherever you are adding something to in a chemical system in equilibrium, wherever you are adding something to, equilibrium will leave that side and go to the other end to balance it up. That is one thing you want to know about concentration effect on equilibrium. Then secondly, what about you removing? When you are removing a species from a system, how will equilibrium constant react? And this is it. If you are removing something, equilibrium will shift to that part where you are removing something to balance up, right? To cushion the effect, to compensate for the loss of what you are removing. So you get the idea. Equilibrium will go to wherever you are removing something. But it will shift away from wherever you are doing what? Adding something. That is how concentration affects equilibrium. So looking at this question, we are trying to remove this copper-2 ion. We are precipitating it out. We are removing it. So what is going to happen? Equilibrium will shift to that side where you are removing something. Which means in this case, if we are precipitating copper-2 ion as copper sulfide, it means we are removing this guy from that system, and that's the reactant. So equilibrium will shift to that reactant side. Now you take a look. If equilibrium shifts to this reactant side, it means the reactant, more of it to be favored. But don't forget that you are removing this. So what is left in the reactant per se will be ammonia. Since equilibrium is shifting to the left where you are removing something, and that is where ammonia is, it means that more of ammonia is going to be produced. So come with me to the option once again. Option A, there will be no effect. There will actually be an effect for removing copper-2 ion. So option A is not the answer. B, the equilibrium will shift to the right. No, you are removing something from the left, from the reactant. So equilibrium will not go to the right. Rather, it will go to compensate that side you are removing something from. Option C, more ammonia concentration will be generated. And I concur to that. That's true. More of this guy will be generated because equilibrium will go to that left-hand side, favoring the production, the generation of more ammonia. Then option D, ammonia concentration will decrease. That's not the answer. So the correct option here is option C. More ammonia concentration will be generated. Option C is correct. More ammonia will be produced. Let me write it. All right, friends. This is the much we can take for our live stream exam focus review with regards to GEM. This is where we are going to draw a curtain. All right, to read. We're going to put a stop to it for our class today. And I hope that you've learned something wonderful from this particular class where we treat the concept of chemical equilibrium. Yeah, just the past question review anyway. Thank you for joining the class. Thank you all for coming, and I look forward to seeing you in our next class. Like I said, I'm going to release a video lesson specifically for this concept of, what temperature will do to equilibrium, what pressure will do to equilibrium, what concentration will do to equilibrium. Follow up, subscribe to this channel, turn on the notification bell, can become channel member. All right, to become a channel member, click on the join tab below this video, and then select the GMAETS 41's platinum or diamond package. All right, so that you can always follow up with our classes. Do have a wonderful day. Take care. Remember to always study your book.